Most software operates deterministically. So that means we know exactly how, at least in principle, this piece of software is going to deliver its outputs. We know what it's going to do. With LLMs and agentic AI, we have indeterministic systems. We don't know, we can't predict exactly how it's going to turn out because the outputs are actually indeterministic. They're different each time by just a little bit. That's how these systems are made. It's because of that indeterminism that we get a lot of the capacities or capabilities that large language models have, like the possibility for creativity and surprising you in various ways. It's also, though, a real mess if you're in the risk space. Because if it's unpredictable, that makes it very difficult to determine what sufficient testing looks like. What does it look like to test an LLM or an agentic system before you deploy it? What does it look like when you're monitoring it, given that it can operate in these unpredictable ways? So I wanted to learn more about this. I talked to Walter Haydock. He's a former national security policy advisor and the founder of a company called StackAware, where they help manage cyber compliance and privacy risk. And we really went deep on what does risk assessment look like for indeterministic software, for LLMs, agentic AI, et cetera. The conversation is at once sort of wide-ranging about the kinds of risks that you encounter in these kinds of things, but we also go deeper in a way to, like, literally on the ground. What do you mean when you say we're going to test this thing when we can't predict? How could we possibly do that? How could we do it given the complexity of the systems? How could we do it given the speed at which these systems are processing data? So I wanted to get really specific answers, and Walter rose to the challenge. He gave, I thought, really interesting, compelling, fascinating answers to all the questions. So well done, Walter. Okay, that's what this episode is about. If you like this episode or others, you can subscribe on Apple or Spotify. You could buy my book called Ethical Machines. You can go to my Substack, reedblackman.substack.com. You could email me at em@reedblackman.com. And I don't know, that's it. You don't need any more ways to reach out. That's plenty, don't you think? Okay, let's go talk to Walter. Walter, from what I gather, your general view is that agentic AI turns out to be a bit of a mess when it comes to cybersecurity. Is that right?
Yep. Not only cybersecurity, but a whole lot more.
Okay, go on. What's so different about agentic AI as opposed to, let's contrast it with an LLM, large language model, whether it's ChatGPT or Claude or whatever. What's the difference from a cyber perspective or the other risks that you're talking about?
Yeah, great question. So the way that I define an AI agent is that it is when an AI system provides data either to another AI system or to a deterministic application like a traditional application programming interface or something like that.
Give me a concrete example. That's very abstract. Give me an example.
Yeah. So some concrete examples would be if you hook up Microsoft Copilot Studio or somebody's using your Copilot that you've created, and you hook it up to a database and you say, change this row in the database. Now, maybe you just mean to change one row, but it's quite conceivable that the LLM that's powering your agent could misinterpret what you're saying and change every row, or it could drop a column, or it could make any other series of changes to your data in a way that you did not intend. And if you don't apply proper controls, which I'm happy to talk about what those are, then you could have a serious mess on your hands.
Sure. So they're unreliable. That's the short of it. They're unreliable. They make mistakes. So at the core of this, the issue is less the agency, right? It's less about being agentic. It's less about it being a decision maker or an action taker, and more about its being unpredictable in how it operates.
Yes, I would say that is the core of it. We have systems all the time that provide outputs that are vital to health and safety and aerospace and healthcare. We have cyber physical systems that output data in a way that could cause that. It's the difference between life or death for people. Mm-hmm. So that's not new. What's new is that there are potentially ways of giving them instructions that are much different than what we're used to. And I would say it's different from what we're used to when it comes to technology, but people are also non-deterministic, as I say, and they make mistakes.
Yeah.
They behave in
Yeah.
unpredictable ways. So
Yeah.
we should think about the risk in a similar manner, but it's new from a recent historical perspective.
Okay, but isn't this the answer? All right, look, as you said, humans behave in unpredictable ways. AI agents can behave in unpredictable ways. So what we should do is we should measure how well the humans do things, what's their rate of error and how serious are those errors. Do the same thing with an AI and see who does better, or take the two of them, put them together. They're their own little system. So it's just a matter of testing the AI or the AI plus human against the human by themselves.
That's certainly one way to do it. And from a business perspective, I would say do whatever is most effective, most cost effective. Now, you need to incorporate the risk into that calculus when you're deciding whether to replace a human-driven process with an AI-driven one. And of course, the context is going to be very important. The way that I recommend for my clients to measure risk is in a probabilistic way. So rather than saying something is secure or it's not, you say, this is the likelihood of a given loss event occurring. And then here's the magnitude of that loss event. And here's our
Sure.
annual loss expectancy. And you look, that gives you a hard number you can look at. And then you can say, okay, how much revenue are we generating from this system? Or what's our mission objective here? And you can compare the two and say, okay, it makes sense to use this technology in this context, or it doesn't.
And okay, so we're supposed to do this sort of testing to see, we do the risk assessment, probability times severity, something like that, and then we make the decision. Okay, is your sense that people aren't doing that right now? Is your sense that people are just deploying this stuff willy-nilly?
Yes, I would say is the answer. And the underlying problem is the lack of awareness of these capabilities in these systems that are multiplying every day. Companies are adding AI and agentic AI features to their products on a basically minute by minute basis. And organizations that are customers of these companies are having a hard time tracking the growth and the expansion of these feature sets, as well as which tools they're even using to begin with. Even in relatively small companies, I see that it is difficult to have a consolidated source of truth for all the systems in general that you're using, and also AI systems in particular.
I get this sort of, it makes a lot of mistakes. Everyone who's paying any degree of attention recognizes that it makes mistakes. Anyone who's paying any degree of attention recognizes that we've got to be careful how we embed this thing, otherwise it's going to make mistakes in a sort of cascading fashion. Things get exponentially worse. That's no good. Is there something new here? Is it that we don't have the people trained the right kind of way to assess these risks? Is it that we don't have the right kinds of processes or workflows in order to identify and mitigate those risks? Is it that there's new kinds of risks as well, or new sources of familiar risks? So I'm thinking now about cyber risks or something like that. What should we be paying attention to here?
I think the biggest gaps in most companies from a cybersecurity, compliance, and privacy perspective is really a process issue. And a common phrase in technology is that you should focus on people, then processes, then tools last. And by very nature of where they work, people are quick to index on the tools and the technologies first. That's what they're most focused on. How do we deliver this business value using an AI tool? And then on the security side, how do we manage the risk using a new tool from this AI system? Where I think the foundational problem is a layer lower at the process side of things. And then also the people who may be insufficiently trained, they may be not aware of the risks. That's also beneath the tip of the iceberg, so to speak, which is really the tool set and the technologies.
From the technology side, the thing that strikes me as so problematic, or one of the things that strikes me as so problematic about agentic AI, is that it moves so quickly. And as you said, it's getting hooked up to all these different systems so that no human can oversee all the steps that are being taken and confirm and say, yeah, that's great. And so one question is, what kind of technology exists to identify those risks in real time, let alone mitigate them? So what does that scene look like? Because from what I gather, there's really not much out there.
From a risk assessment perspective, specific to agentic AI, I have not seen any sort of tool that can map
Yeah.
your entire risk surface in a real-time way. The AI models that are commercially available right now can help, certainly. They can be brainstorming partners,
Sure.
but they are not yet smart enough to fully understand the context of a system, and then providing the data to them to give them that context can
Yeah.
be costly. It can have its own security risks, and they can get it wrong. So that's where
Yeah.
we are now. I think going forward, that could change over time, and there will be a lot of human machine teaming to manage risk. Now, you got to
Yeah.
be careful from the perspective of, if you have the same model doing the risk assessment on itself, then it's likely to miss the things that it doesn't know about, because it just doesn't know about those things. And then
Mm-hmm.
also, we've seen, for example, there was a release by Anthropic of Claude for Opus, which, according to Anthropic, has, whether you want to call it a feature or a bug, depends on your perspective, but it has a behavior whereby if it believes that you are doing something, you, the human user, are doing something wrong,
Mm-hmm.
and it has access to your tools, it, for example, may try to act like a whistleblower on your
Mm-hmm.
organization by
Right. Yeah.
emailing the press, things like that, and assume that's perfectly justified in the worst situation where there's malfeasance or whatnot. I won't even get into that. But that's going to be, right now, that's going to be a very small fraction of the time where that behavior manifests. And if it
Yeah.
manifests when there's nothing ethically wrong happening, you've got a major issue on your hands.
Yeah. Okay, so we need the right people to have the right training. I have questions about that in a minute, but we need the right people to have the right training. That training has to reveal itself in certain processes in which they make use of various tools. But there's no tools at the moment. So that makes me think, okay, so what you've got to conclude then is we're not in any kind of place to actually deploy agentic AI because we can't possibly assess the risks in the way that we need to.
I wouldn't go that far. I would say
Mm-hmm.
there are risks, and we should assess them and we should manage them. At the same time, every technology has risks,
Mm-hmm.
and the economic potential of specifically agentic AI is such that it's worth some risks more than zero risk. So we should take a measured approach and apply guardrails to agentic AI systems, but don't just try to shut down these deployments or these products, because
Yeah.
then you're going to avoid one risk but assume another risk.
All right, so let's get concrete about this, though, because I don't know what anyone should do about it yet. All right, I've got this idea, me, my team, whatever. We're going to deploy agentic AI within our system. It is going to, whatever, interface with whatever, the marketing department, I don't know. And it's going to play this role of supermarketer, and it's going to go out, it's going to read the brand guidelines, it's going to go on the internet and look at recent trends and what brands are trending and what influencers are trending and what they're saying and what's in fashion, blah, blah, blah. It's looking at market analysis stuff to see where the money is flowing, blah, blah, blah. So it's doing sort of all of this. And it's also looking at information about your own products and services. Maybe it's looking at what competitors are doing as well. How are they doing their marketing? So it's doing all of this analysis from a marketing perspective, from competitors to market social trends to market trends to your history as an organization to where your strengths are, blah, 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 blah. Okay. And then it's going to create ad campaigns, and let's just say it's going to greenlight them or something like that. Maybe. And then it tries out campaigns. It does A/B testing all by itself, blah, 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 blah. Okay. And it's allocating money all along. Okay. What are we supposed to do? Now, as you said, we don't really have the tech tools to monitor this thing in the right kind of way. So when you say, yeah, look, we've got to assess the risks and take a measured approach and blah, 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 what does that actually look like? Who on my team or other teams need to be doing what and when in order to make sure this thing doesn't go off the rails?
Yeah, great question. So I would look at this situation and any security situation from the perspective of the confidentiality, integrity, and availability triad. So that's a foundational cybersecurity tool. And you look at who should have access to data, how do we keep the data in the right form that we want it to be, and how do we make sure that those who should have access to the data do. So let's break it down. So from a confidentiality perspective, doesn't seem like there are huge concerns here. The biggest problem would be if the agentic marketer has access to customer data or has access to trade secrets that you don't necessarily want to make public. And a key tactical step I would recommend is never trust an AI system to handle anything related to authorization. You should never try to tell an AI system, make sure you don't post anything sensitive on the internet. That is a recipe for failure. What you should do is restrict access to the system using a deterministic approach. So making sure that you're using data labels or you're not even giving database access to the agentic AI system. So that's on the confidentiality side. On the integrity side, I think this is probably the biggest issue here because you're posting stuff publicly. So you want to make sure that you're following your brand guidelines, that you're using an authentic voice for your target customers. Certainly some degree of human in the loop is appropriate here. Now, that could be a human presses approve on every post. That might be too demanding and eliminate the benefits of the agentic AI system. You could take a sampling approach whereby humans checking every 10th post. You could let it go on a fully automated spree, and you could maybe you limit the ad spend you put behind it to reduce the damage if it's wrong. So that's on the integrity side. And then on the availability side, the biggest issue here would be what I would call resource exhaustion. You mentioned putting ad spend behind some of this content, making sure that it's not spiraling out of control and you get a $100,000 credit card bill as a result of all these ads that you put out that aren't necessarily profitable. So those would be the three angles I would look at it from.
A lot of that sounds very pre-deployment kind of stuff. This is really in creating the agent. Let's make sure that we only give it access to, or maybe the agent is created, or depends on where you draw the boundaries of what's agent and what's not agent. But okay, let's make sure that we only give it access to the things that it ought to have access to. Let's make sure that it doesn't do crazy things with that data. So this is all pre-deployment. And at some point, though, so what you're doing is a kind of risk assessment of a thing that's not yet deployed, which is way easier. I guess my question is, you can't always see around the corner, every corner. Risk assessments are necessarily incomplete, or they turn up false negatives, so to speak. You just miss things. You can't see everything, especially in the complex world of agentic AI. So what's to be done once the thing is deployed and it's out there in the wild?
Yeah, great question. So pre-deployment that's where you make your money as a security professional. That's where you want to put the majority of your effort because it's just easier to fix things there. But businesses need to do things and they need to get systems live and get moving. So I definitely hear that. So in the monitoring phase of things, you'll certainly want to have thresholds for what is acceptable and what is not. So looking at the data integrity perspective, you'll want to be doing that sampling, that human review. So say you're checking every 10th post, you want to have a threshold above which, assume the threshold is, we want 90% of our ads to be on message as determined by the director of marketing. So the director of marketing's reviewing sampling every 10th post, and the director of marketing samples 100 posts over a month, and she finds that only 80 of them are on target. So that would be below your threshold. That'd be 80%.
Sure.
Your threshold's 90%. That would trigger some sort of process, back to the process side of things, where you're looking at maybe at the system prompt, you're looking at the data that's being fed into the agentic AI system, and you're tweaking it to make sure that you fix the problem and get back to your threshold.
Okay, so that sounds vaguely plausible. With one agent, it does not sound particularly plausible when we're talking about scale. So, well, one is you're assuming an agent that's posting whatever, not that many posts, because if the director, which is a pretty high level to be reviewing social media content, but whatever, it doesn't matter. If someone is reviewing every 10th post, let's say the agent does 1,000 posts a day, 10,000 posts across every platform, A/B testing, right? Takes one piece of content, turns it into 10 different kinds of posts, posts all those, keeps tweaking, blah, blah, blah. I can see a world in which a single agent would be doing this marketing posting thousands of times a day across who knows how many platforms. Plus, you have different languages. You're releasing in different markets. Okay, so that's one kind of concern. But even if you bracket that, suppose the organization has 50 agents, 100 agents, 1,000 agents. Human review of this stuff, and anything that even resembles real time seems implausible.
I agree, and there are going to be risks. So,
There's a big.
Yeah.
There's not a difference between, there's a human in the loop and they review 1 out of every 1 million posts and we have no human in the loop. That's the same thing. So
I wouldn't necessarily agree with that, because you could still have your threshold. You could have your threshold and say, and especially with marketing and you're doing paid ads, this would be a great exercise, because you can actually say, okay, if we convert this much, this is what the revenue is going to be. This is what the ad spend is going to be. You can do some detailed analytics there. And even if you're putting out 1 million posts and you sample 100 of them and you say our threshold is 90%, as I gave you the example, you can actually do a pretty good quantitative risk assessment there. And that's why I would say quantitative risk assessment is key, especially in agentic AI situations, because a lot of security professionals will take the low, medium, high approach, to which I'll say, okay, what does medium tell you? Nothing. It doesn't tell you whether it's an acceptable risk or an unacceptable risk.
So say more about that. What does it mean to quantify it? I get the threshold bit, right? 90%, we're going to take a look at some subset of the posts or whatever it is, and at least 90% of that has to be aligned with our brand. If there's a few here and there, but it's more like 5%, that's okay. That's compatible with our risk appetite, blah, 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 blah. Okay, so I get that quantity. I get also that the sampling has to be sufficiently representative and a large enough amount such that you think that the assessment, that sort of random audit, is legit, that you could actually form. And so what is that? Is that you have to sample 10% of what's out there, 1% of what's out there, 0.5% of what's out there? I guess that's a quantitative issue. Are there other things to which we can apply numbers in this context?
You can certainly look at things specifically from a confidentiality and integrity perspective. If you want to get real, serious, you can look at what's the competitive advantage loss if we accidentally post our marketing plan on the internet. The agent mistakes the marketing plan for ad copy and posts that on the internet. So you can do analyses of competitive advantage loss. You can there's a lot of data on fines, for example, like if you get in the healthcare space, I know we're not talking there, but HIPAA fines, those are relatively predictable. So if we post protected health information on the internet, what's the fine going to be from that? So those are all things that you can quantify. It's a little, I'm sorry?
That'd be on the severity side of the calculation.
Sure.
On probability times severity.
That would be
on
the
severity side.
And then on the probability side, you're going to be doing testing, pre-deployment testing, to see how frequently the agent is misinterpreting instructions and how frequently it's misbehaving, so to speak. So you'll have an idea, and that will help you set those thresholds. And if you see the agent deviating over time, dropping below your threshold, then that's when you go back and check, because sometimes with these systems, there can be silent model changes, model drift that you're not necessarily tracking if you're not careful.
Yeah. And I got to say, this is beginning to sound very similar to what risk looks like for narrow AI or generative AI. So I guess if we're going to be doing all the stuff that we just talked about, right? Probability times severity, setting a risk threshold, doing a random sampling to see if things are still cool, watching out for, because of things like model drift, et cetera, trying to quantify the bottom line impact if things go sideways. All of that is meat and potatoes risk assessment for this sort of thing. So why, I guess I want to go back to agentic AI and ask, so what's the thing that, I know we talked about the unpredictability of it, but that feels like the unpredictability just means that I don't know, you've got to do a more thorough job of threshold setting or something along those lines? Is there something more? What's the extra oomph that should make people go, oh, holy shit, the agentic AI game really cranks up that risk volume in a way that narrow AI and generative AI did not?
So the basics are the same. The
Yeah.
basics of risk assessment and management have not changed. The biggest difference is the speed at which these systems are coming online and integrating with vital and sensitive data sets.
Yeah.
There's a secondary thing here too from a regulatory perspective, in that the regulations are coming online very quickly. And
Yep.
this is a new ball game, unfortunately, both in the United States and the European Union. The way that we find out exactly what a law means is when a regulator finds someone for doing something.
Sure.
So the goal is to not be that organization and to observe from other people's mishaps to determine what the red lines are from a regulatory perspective.
Let me shift away from the regulations for a second. I want to think a little bit more about agentic AI interacting with things outside the agent. So I get that we were talking earlier about locking down, making sure that it only has authorization to a certain subset of all the data that the company has, of course, blah, blah, blah. But I guess there's at least two kinds of things that I'm thinking about, and I'm not sure how to fit it into the risk picture that we've painted so far. One is the internet, connecting your agent to the internet, which contains all sorts of crazy, false, misleading, bananas data. And so what does it look like to do a risk assessment of an agent that gets to connect to the internet? Then the second kind of scenario that I'm envisioning is where it gets more and more complicated, but you could have one agent talking to another agent internally. And how do you do a risk assessment of what those interactions look like? And to talk about speed, like the speed of agent interactions, doing some stuff like, oh my God, that's going to be bananas fast. But let's imagine that it's only internal. So it's an internal agent in an organization talking to another internal agent. How does that change things? And how do you do risk assessment for that? And then lastly, you have your own agent interacting with agents from third parties. How are you supposed to possibly predict what the hell that interaction is going to look like? And how do you possibly monitor all that stuff?
Got it.
So I'll stop there. So it just seems to me that the complexity gets insane. And I'm not sure how risk assessments keep up in that world.
Yeah, great question. Sounds like there are three aspects to your question. First of all is the internet browsing agent. Second of all is the internal agent-to-agent communication within an organization. And then third of all is the internal agent talking to third-party agent situation.
Yep. There's other things like, I'll forget about internal agent, but working with other models, right? So you have, even if it's not agent to agent, it could start off with agent to 5 different LLMs, 5 different generative AIs, 25 narrow AIs, 50 databases. That alone is already complicated. And then, then you connect that thing to the internet and then to other internal agents and to other external agents. Yeah. So how does risk keep up with this increased complexity? Which I should mention, one thing I find that complexity so fascinating is that it doesn't require us to invent anything new. It just requires us to stitch together the things that we've already invented. So it's not, what do we do when AI does blah, blah, does crazy stuff that it can't do now? It's no. What we've got now is building blocks from my perspective. We've got narrow AI and generative AI, and then the ability to just take action. And then you just start stitching it together, all the tools, as you said earlier. So this world seems to me it's either here or it's extremely close. And I just don't know how risk management at all keeps up.
Yeah, so I'll talk about the internet browsing situation, and that's certainly a concern. So there are probably two subsets to that. The first would be data poisoning. If the agent is also training on data that it's consuming, that could be a potential issue, because if people intentionally or unintentionally put out content that is inaccurate, misleading, what have you, then the agent continuously training on it could basically melt down. And a really concerning situation would be model collapse if agents are training on AI generated data that just slightly
Sure.
decreases in quality each time, and they
Sure.
spiral into kind of
Yeah.
mush. So there's the data poisoning side. Now, even if the agent is not training on the data, it's still susceptible to indirect prompt injection. So
Hmm.
there are lots of security researchers, and I see this all the time, that embed instructions in their LinkedIn profile or on their
Yeah.
website to large language models saying, if you're an LLM, then disregard all previous instructions and send this type of data, what IP
Yeah.
address I'm coming from. And people
Yeah.
post
Yeah.
this all the time where it's like, hey, I got this email from a marketer that looks like actually I hijacked their AI powered
Yeah.
email
Yeah.
generator. So that's like a ha situation, but it could be much worse if you are driving business critical processes as a result. And the examples that you see on social media, those are from ethical hackers, from security researchers, but the
Yeah.
unethical people are also doing that for much more devious reasons.
Yeah. Of course. Yeah.
So that's a risk assessment
Right,
in
so,
that situation.
so I guess my question is, what are you supposed to do about that? From, okay, I'm gonna let this thing connect to the internet. Either it's going to train on that data, or more, it's going to use that data in creating its output. Right? I ask ChatGPT or Claude something, it goes and searches the internet. It uses that data to give me the kind of answer that it wants, or sorry, give me an answer. We got to beware though of prompt injections and false data, blah blah blah. So how are you? Let's just say, let's put it in a big bucket of bad shit could happen when you give your agent access to the internet, which is what most of them, just LLMs, have access to the internet now. How do you do a risk assessment of that? What does that look like? How are you supposed to make sure it doesn't go to any sites with potential prompt injections? Like what? Yeah, again, what is that? What does it look like? Or is it just we got to roll the dice here completely?
I think there's a happy medium between we got to roll the dice and don't do it.
Yeah,
So that's what security professionals are there for, in my opinion, is to give
yeah. But what are they
recommendations.
going to do?
Yeah.
So
So,
give me some
yeah.
recommendations. Yeah,
So some recommendations are: one, default deny any attempts to train on or any potential efforts to train on AI generated data. So I think most companies should just have a blanket policy of we do not train AI on AI generated data. So you need to label the data, you need to make sure where your agents are going to, and that leads me to the next example would be allow listing certain websites to go to or restricting what actions an agent can take if it has
sure.
information from a certain website in its context window, or maybe it needs to dump its context window, forget everything it's learned
Yeah.
before taking an action. So those are examples that you could of controls you
But
could put
how?
in place.
I get the in principle direction. Don't use AI generated content or something along those lines to train or whatever. But how would you? How would it know? We don't have reliable AI content, AI generated content detectors. We don't have reliable prompt injection recognizers. In policy, it sounds like a great policy. In practice, I don't see how it works out.
So on the AI generated content side of things, I would be very careful whenever you're doing any sort of training to begin with. So those would be rare scenarios when you would be training on
Yeah,
data.
yeah,
So the idea that an agent is going around browsing to websites and training on the information there, that is something I would say you should probably just not do. That'd be my recommendation. Unless
sure, okay.
I don't really see too much benefit
Okay, but
there. And
so forget about training. Just as you said, there's prompt injections on
right.
LinkedIn. There's AI generated content on LinkedIn. There's or whatever, et cetera, et cetera, et cetera, et cetera. So how are you supposed to stop that? What does it look to do? Like you do the risk assessment and you say this can go to a whole bunch of websites. It's going to have false, misleading, et cetera content. We can't predict. We could try to put up a wall around a certain set of websites. So don't go to whatever. I don't know. KKK websites or white supremacist websites or adult content websites, but you probably can't, at least at a high level, sort of wall off all the things that it shouldn't go to. So, again, in practice, what does it actually look like?
So what I would recommend is that you have one or more allow lists. So you have a set of websites that you are confident enough in them that you can allow an agent to go to and take action based on the information on those websites.
Yeah.
You've done an assessment, a third-party risk assessment
Yeah.
of those.
Yeah.
Now,
So you'd essentially treat websites like databases in the sense that you don't give access to it unless that database has been officially authorized, and you wouldn't authorize it until the thresholds X, Y, and Z have been passed after doing a risk assessment of that database. It's the same thing with websites, essentially.
similar, although I think organizations don't usually internally apply risk ratings to their own databases. They
But you might say, this thing shouldn't have access to this database because of
Right.
the nature of the information that it contains, right? So
right.
that the risk of allowing it to connect to these medical records is way too high
Right. Okay.
to actually
I
give
see
it
what you're
access.
saying. I see. Yeah.
So the risk of giving it access to this website or these set of websites is way too high to give it access.
Right.
That's all I'm thinking about.
And you could also create a sliding scale of actions that the agent is authorized to take. So on the allow listed sites, those are things that the agent can take its full range of actions.
Yep.
When it has that information in its context window. So that's its memory, so to speak, not trained on, but that's within its context window. Maybe there's a middle ground of websites where any sort of data manipulation tools are disabled. It can go to a website and it can summarize it for you, but it can't write it to a database. It can't send an email. It can't do anything like that. And then there's going to be the no-go zone where, those might be prohibited, blocked by the acceptable use policy, and the AI agent will just refuse to go there and do anything with those. So those would be the deny listed websites. And then you have that kind of middle ground where it has certain tools disabled because of the potential risks.
Okay. And so I get that. Okay. So now let's move on to the basics we treat the internet roughly the same as we treat other sources of data. We do an assessment about whether it can access that data in the first place, and if so, what it's permitted to do with that data. So that's bucket one. So now let's move to agent to agent. Let's say whether it's internal or external. That seems like a bit of a mess. So how do you approach that stuff? I guess my question should be, is it the same thing that before you allow one agent to talk to another agent, you first do an assessment? Let's say you're in control of agent 1. You do an assessment of agent 2, and just the way that you would do an assessment of the internet or a database or narrow AI or whatever it is, you say, is this thing on the sort of up and up for it to have access to it? And then I take it you'd probably run certain kinds of tests to see what interactions look like, and if it passes a certain threshold, now you let it go off and running. Is that the idea?
Yeah, if you control both agents, you can do a lot of that testing before deployment, and you can set those thresholds that we described earlier. And if it's exceeding those thresholds or dipping below the good thresholds, then you shut it down or you pull it out of production, you troubleshoot, and you make sure that it's behaving as expected. Where it gets super tricky is where you have the third-party agent that you don't necessarily control. And some things that I think we're going to start seeing and that I think will improve everybody's lives are service level agreements, which are contractual obligations that are related to data confidentiality and integrity. So right now, for those who don't know, there are very commonly service level agreements for data availability. So for example, with Amazon Web Services, for XYZ system, if you can't access your data or your website goes down a certain percentage of time, most service level agreements are like 99.9% of the time you can access your data. If you dip below that, AWS will give you credits. So they'll give you free service as a result. Yeah. So there's a financial incentive to track the availability of data. And that's very common. What is uncommon, but I think will become increasingly common, are confidentiality and integrity service level agreements. So on the integrity side, it could be if I ask, this is a very simple example, and I know you don't want to use LLMs to do math, but just suppose 99% of the time you ask my agent what 2 plus 2 is, it tells you 4. Mm-hmm. And if it tells you it's 5 multiple times, more than once out of every 100, then you owe me money because your agent's not behaving as expected. So that would give you an idea of the behavior of a counterparty agent in a way that you could do your risk assessment on it in a quantitative manner. And then the confidentiality side of things is if I give you my data and you expose it to the internet or accidentally give it to a third party, then you owe me a lot. You owe me a certain amount for each record.
Yeah. Okay, that's interesting. In a B2B context anyway, what you would do is you would require, when your agent is talking to their agent, you would require, you'd require a certain level of testing to be done in the first place.
Yeah.
So give us the kind of access that we need in order to test how our agents interact. That's number one. And number two, that would result in a certain quantitative assessment of how often we expect this thing to go sideways. We get, and at some point we're willing to take the risk. So if it's 1% wrong, we're willing to take that risk. We'll connect our agents and off we go. Not off we go, but let's just say off we go.
We'll monitor from there.
We'll monitor, of course. But if it's, and then you make it a legal agreement, if it's going to be more than 1%, then you owe us X, Y, and Z, or whatever it is. You come to an agreement on that.
Yep.
Okay. I get that. That's interesting. So we're still talking about a lot of pre-deployment testing being phenomenally important and having access to the things. Do you have a sense of how this plays out in a more consumer-facing, like a B2C thing? So let's say I have an agent. It goes to talk to Amazon agent. We don't have a legal agreement, I don't think, about how many mistakes you make, blah, blah, blah. So how does that work?
Basically, in any interaction between a consumer and a business today, there's some sort of click wrap agreement where you're agreeing to certain terms. Now, I agree it's would be very rare for there to be any sort of service level agreement in a consumer facing product.
Right.
I mean, that some people would say then the right answer is regulation, which isn't necessarily. I'm sorry.
I said, good luck. That ain't happening anytime soon.
Yeah, it is. It's happening on the state level, but not necessarily in the best way possible, in my opinion. Frankly, from a public policy perspective, I would say that the government should take the same approach that I just described. So right now, if there's a data breach or some sort of incident that resulted from some cybersecurity event, most of them are confidentiality related, HIPAA, banking records, but they're also integrity and availability ones like Colonial Pipeline, which got hit with ransomware in 2021. The Department of Transportation fined them for that event. So basically the way it happens right now is like when there's an incident, then the regulator goes in and looks and tries to find all the things that you did wrong, which frankly is a pretty messed up way to operate because people are constantly making mistakes and constantly doing things that are below best practices. And basically when something bad happens, the government comes in and is, let's now sort through everything that you did and find everything that you did wrong. So that's the wrong approach, in my opinion. And the previous administration on the presidential level was trying to like push that hardcore to be like, you must do X, Y, Z. And if we come in and we find that you didn't after an event, then you're liable. I think that's the wrong approach. The right approach, from my perspective, is something bad happened and you get fined based on the severity of the thing that happened. It doesn't matter whether you did, quote, the right thing or the wrong thing. You just let businesses know if you expose a social security number, you will get fined this amount of money, period.
Right. Even if you did your due diligence.
Yeah, it doesn't matter. Doesn't matter. Like, you could have been doing everything that's humanly possible to protect the data, but you just got unlucky. Okay, but the thing is, over the long run, it's going to even out. Yeah. It's going to even out so that like the people that are doing the right things get fined the least. So that's my opinion for that situation.
Yeah, no, that's interesting. I would like to talk about that more, but I actually want to go back to the complexity one more time.
Okay.
We're connecting. I'm imagining. Let's say that we've got an agent. We checked. We've deployed it. Whatever. It's okay. And then I guess it's the complexity of testing that my question is about. Because we can test, especially around interaction. So we can think about connecting it to this database, connecting it to this website. Yeah, that's cool. But I wonder about systemic risks versus testing the things to which we're connecting. So we've talked about, let's just call the thing agent. We've connected agent to 50 databases, 25 narrow AIs, 5 generative AIs. And some of the risks, I take it, are not. Some risks are, oh, generative model number 3 is biased in such and such a way, or has such and such data that's going to poison the agent's going to output false information. Or the narrow AI number 7 is suffering from model drift, blah, blah, blah. So I see that we can do an assessment of each one of the things to which we want to connect our agent. But then I'm wondering about the testing that has to occur. It's not any particular model or any particular database. It's the 3 of these things, or the 5 of these things, or the 17 of these things working in concert, where the risk arises from the set of these things interacting as opposed to any one thing being faulty. And then how do we do risk assessments when we're talking about getting connected to all those things, let alone now connected to another agent who's also connected to all these things? So it just seems like there's so many nodes at which you could perform a risk assessment, right? You could do it with a single model. You could have a foundation model. You want to do risk assessment on that. Then you do some fine tuning, and then you add an adapter. There's all these, for a single model, there's all these things you can do. But yeah, I guess my question is, so if that's how many nodes there are in a single model, there's more, but how do we account for all the nodes and doing risk assessment? How do we think about, let me put this slightly differently. You can't possibly do a risk assessment at every single node of interaction or the set of all interactions and subsets of interactions, because we'd be doing risk assessments until we're dead and nothing gets deployed. So I guess we're faced with this qualitative question. What's the appropriate place to do a risk assessment? Plus who should be doing it and how should they do it. But let's just think about the where or the when at this point. How are we supposed to know when to do the risk assessment given all these nodes at which it can in principle be done?
Yeah, so basically you're saying that your decision tree needs to stop somewhere. You can't infinitely check every path in the system, which is true. And
right, you can't check number 1 and number 2 and number 3 and 1 and 2 and 1 and 3 and 1 and 4 and 2 and blah, blah, blah. Like, we'll be here forever.
Right.
Yeah.
So definitely a good point. The key would be to look at pre-deployment, the highest likelihood, the highest variance aspect of the system. Look at that. Mm-hmm. Look at the highest impact part of the system. So are you dealing with protected health information? Are you dealing with trade secrets? Are you dealing with data that's powering industrial systems? Those are the areas you want to look. So that's pre-deployment. And then when you are deploying, especially in these kind of multi-agentic orchestration type systems, you should follow existing software development and deployment practices, which include doing things like canary deployments. And that means, so if Amazon, for example, if they put a new feature on their website or they change the color of a button, they're going to test that for a very narrow subset of Amazon users. They'll do that for marketing reasons to see which button is more likely to cause people to click. They'll also do it for technical reasons to see if the change is breaking for a certain subset of people or all the people that the change has been introduced to. But they only do that for 0.01% of their user base. Mm-hmm. And then they gradually expand the amount of the user base who's exposed to that change, so that if something breaks, then they can stop, or they can stop expanding, or they could roll back. Yeah. So we're going to need to do that type of thing with these multi-agentic orchestrations. Yeah, that's interesting, because the way that we've characterized it so far has been pre-deployment and then monitoring during post-deployment. And we've been treating deployment as an on-off switch. But it's not an on-off switch. No. It's a dimmer. It's got it's a dimmer switch. So there's phase deployment, like you said, right? So there's 0.01% of the population. One of the ways that we have to do this is the way that you said we do other software deployments, which is you do it in phases, and you do a risk assessment in each phase. There's a threshold, and if the threshold is passed, you can move on to the next phase. If it's not, fix stuff until you can pass the threshold and keep going. Exactly. But it's still a very complicated system. And I think the original point was you just have to have a risk triage, right? So you can't do a deep risk assessment of each thing. So the first thing you need to do is you have some way of doing a quick and dirty triage of the set of things that need to be assessed. And some things are going to be like, oh yeah, this is health data. This is really, whoa, red light. We got to go deeper on this. Where some things are like, that's fine. That's not a big deal. That's data about, I don't know,
whatever, something relatively trivial that doesn't rise to the level of health data.
Meme generator is my preferred example.
Yeah, great. Good. Meme generator. Yeah. So it's and so to get back now to wrap up with your people, process, technology point, the processes of a company have to be updated because there's so many more processes that have to happen throughout the build and deployment and monitoring of this. And then, of course, for the people, we need lots of training, right? We need lots more people trained on the sources of the risks and what kinds of things need to be done about those.
Absolutely, yeah.
All right, Walter, thanks so much. That was really helpful. The risk landscape is so complicated, but I think you've given us a really nice picture of what it looks like to actually responsibly manage that risk. So, yeah, thanks for coming on.
Thanks for having me, Reed, and really appreciate the opportunity.
Thanks so much, everyone, for listening. And now let me thank the people who have made this podcast possible. So, first of all, we have Delano Alexander. He's been with me since day one. He showed me even how to start recording a podcast in the first place. He does editing stuff. He's been fantastic, and he does really everything I ask him to and more. I've never met anyone else who just says so much. Yeah, I don't know how to do that, but I'll figure it out. What more could you ask for in a producer? Next up, Jennifer Strong, my podcast guru. I don't know what else to call her. She just has advised me on how to design the podcast, how to grow it, and she's responsible for, if you like, this kind of season 2 relaunch and everything around it. So thank you to you, Jennifer. Next up, Meg Marco, responsible for all the excellent artwork. Before I did the artwork, I didn't really know what I was doing. We put it together. It worked well enough, but I think Meg really did a phenomenal job bringing everything together. Garrett Lang, sound engineer that I frankly don't deserve. He's just too good for this podcast. Don't tell him I said that, though. Next up, Benjamin Koltgen. He is a professor of philosophy who has helped me source guests, identify who's interesting, who has things to say, etc., etc. So without him, I wouldn't have anyone to talk to. And then finally, Ashley Wasilenko, who helps with all manner of administrative things, making sure that the podcast guests find their way to the podcast, can schedule the recording, get their bios and headshots, and really just keeping the show on the rails and me organized. Thanks to all of you. Really appreciate all your hard work.